Okay, so this question is about connected particles. This question says two particles A and B with mass m and 2m respectively are connected by a light inextensible string. Now, the words light inextensible string has two modeling assumptions. When we say inextensible, we assume that the acceleration between A and B is the same. And also when we say it's a light string, so the mass of the string is negligible. Therefore, the tension of the string throughout should be the same. So these two modeling assumptions will be used, and the string passes over a smooth pulley attached to the edge of a rough horizontal table. The particle A is held at rest at a distance of 2a from the pulley, and then when the string is out, B is hanging vertically below the pulley, so the system is released from rest, and we've been given the coefficient of friction as 3/5. You can see here it's 3/5, and they say when A is released, you need to find the acceleration and the tension, and in the subsequent motion after B has fallen the distance of A, it hits the floor, and it says it does not rebound. So we need to show that A finally comes to rest at a distance of 2/9 A from the pulley. So this is what the question is all about. So let me show you the diagram first. So here is my diagram. So in this diagram, you can see B is hanging vertically, and B has a weight of 2 mg. The weight of A acts downwards as mg, therefore R should be equal to mg, and most importantly the coefficient of friction is 3/5. So when we apply F equals ma for B first, it should be 2 mg downwards minus T equals to 2 ma, and for A you can see friction will be acting in the opposite direction. So those are the two horizontal forces. We need to indicate that as well. So A we say is going this way, so T minus mu R is equal to ma. When you add equation number 1 and 2, we can say acceleration is equal to 7g/15, and the tension in the string is 16 mg/15 newtons. Also we can say when B has fallen a distance of A, so the tension will be 0. So over here it has to be distance of simple A, the tension is 0. And also when B has fallen down, you can see here there is no tension, so A has literally moved this distance of A, and still it's moving with the speed of u. So let's find that speed u first. When B hits the floor, speed of A is same as speed of B, so v square minus is equal to u square plus 2a. So we finally arrive v is equal to root of 14 ga/15. So this becomes the speed of u when the moment B hits the floor. So after B hits the floor, when you apply the same equation to A, you can say the final velocity is where it comes to rest is 0. The final displacement, it travels the distance between the point where A comes to rest and the point when B hits the floor where A was. This distance is s. So you can see s is equal to 7a/9. So the total distance traveled by A is 16a/9, which is A plus 7/9a, which is 16a/9, and the distance from the pulley is 2a/9. That is a show that question, so we got the answer. Hope you understood.